Just like Earth has a magnetosphere, a magnetic shield that protects our planet from solar and galactic radiation, the solar system has a shield of its own. The Sun produces this magnetic shell known as the heliosphere. It extends out past Pluto, the Kuiper Belt, and the Oort cloud, and protects the entire solar system. Clearly, this field encompasses Earth and Earth's magnetosphere, and they interact on a regular basis, approximately every 8 minutes, canceling out, creating what NASA calls a magnetic portal, and charged particles from the solar wind enter freely into Earth's systems. This is called a flux transfer event. Now, there is incredible variation to these events, and during the severe ones, many agencies and individuals go on alert. We know that solar flares cause radio blackouts that last as long as the flare does. But when these magnetic portals are surged by a solar eruption, the influx of particles can be severe enough to cause a radiation storm at Earth's polar regions. These strong connections can cause multi-day storms. The most severe storms require astronauts to enter safe rooms aboard spacecraft. Air traffic control begins to reroute high latitude and polar flights to avoid exposing passengers to increased radiation. If one of these events was big enough, it could theoretically be dangerous to even stand on the ground near Earth's poles. We have a fairly good way of detecting these connections, which scientists believe look exactly like you would expect a portal to look, and tracking them all the way back to our star. It's not just on Earth either, but we can track them for the other planets too. The alternating black and white segmented lines curving from planets back through the central sun are the interplanetary magnetic field lines along which many of these radiation events are driven when energized by a solar eruption. This is known as the Enlil spiral. We even monitor the dominant connection point where solar activity is most likely to cause increased flux events. Currently, the GOES satellites monitor this radiation, specifically in terms of proton influx. There are both proton and electron events, and the major events are very rare. It's important to know that no person has ever been directly harmed by a space radiation storm. These events range on a scale from S1 up to S5, with S5 being the strongest, where satellites and spacecraft are under significant threat, along with some airline passengers. Those events are extraordinarily rare, and to be in danger on the ground would require an event off the charts, like an S6 storm like humans have never seen. Solar energetic particles in these radiation storms can arrive within minutes of a solar flare and last for days. However, the most significant space weather events come from coronal mass ejections, CMEs, the most prolific makers of the auroras. The Earth-directed CMEs send particles towards Earth that impact Earth's magnetosphere, compact it, and energize it, causing disruptions in Earth's magnetosphere that can cause electrical disruptions from satellites all the way down to ground-level transformers and electrical grids. Scientists are beginning to understand that all major solar events have effects on Earth's atmosphere, and how these strong events create geomagnetic storms, where Earth's magnetosphere becomes unstable during a CME shockwave, and in the wake of the impact. In the worst-case scenario, these solar events could cause disasters here on planet Earth. It has been almost 160 years since the last mega solar flare, or megaflare, and back then it was not very dangerous to our way of life. The next episode details what will happen during the next megaflare, when it happens.